Thank you. So now we're going to take a break from the regulation background, the different ideas for collision avoidance, and focus in on some of the unique sensors that we're creating out there to go on UAS systems. Not sure if they're all going to be small UASs based on the size, but we're going to get there. So we already know about the challenges here. That's what we've been talking about all week, so I'm going to jump through that. And before I dive into my talk on different survey techniques that this will allow us to do, I'm going to give you a brief background on Regal in case a lot of you in this area aren't unfamiliar with us. So we have over 20 years of innovation and experience. I'm from Regal USA out of Orlando, Florida, and this is actually our 20th anniversary this year. So we have a complete portfolio of sensors, and we really understand what surveyors are expecting in terms of data quality, precision, and accuracy. And so with our new VUX1 sensor, we've designed it to meet this UAS challenge and this industry's expectations, hopefully. So the way we see it, we have defined our four traditional survey areas with our aerial sensors. These are for large aircraft flying at thousands of feet in the air. We have our mobile sensors on vehicles that are driven by people. We have our tripod sensors that are, throughout the world doing surveys for road construction or for tunnels, buildings, all that kind of exciting and applications. And then we have industrial laser scanning. But now with the unmanned laser scanning segment that we're starting here, we really see a way for it not just to be its own section, but really to tie into all the other parts. And so I'm going to toss up a lot of information today for your reference material for later on about the specific specifications of the sensor. But what I really want to focus on is the unique ability UAS and UAV technology allows surveyors to use it and explore new areas and provide more information to their clients that really isn't available when they go out and do traditional surveying. So when we look at each of these areas, the mobile, the tripod, the terrestrial, and the industrial, you can only see things with lasers as far as line of sight. And so if you're limited to line of sight from the road, for example, you have different limitations that you can't see beyond the edge of a ditch, for example. So you can't get that full profile. And here is where unmanned air systems will be allowed us to go out and get those areas we can previously can't fully capture. So if we look real quick at some of the capabilities we've done in the past, we started out with a much larger instrument, the VQ 480U, and we've been putting that on several unmanned vehicles. We also now have our VUX1, there we go, this is a 3.85 kilogram package, very nice lightweight sensor. And then a heavier package that we created was our 820GU. And this we actually integrated on a Regal aircraft. This is not a small UAV at all. It's a very large UAS sensor platform. But this one now is a very unique position to help us really capture this industry's area. So some of the highlights of the instrument, just to give you some background on what its capabilities are. So we call it very lightweight. It's very compact. It has a very high laser pulse repetition rate. So that's the number of points it can pulse per second. So we're having 550,000 shots in the air. And it has a scan rate, which means the rotation of the mirror inside of it is scanning at 200 lines a second. And we expect to have operating altitudes of 1,000 feet in terms of range. Obviously, there are other parameters to consider in that. And our precision scales, we're at the 25, where are we? Yeah, 25 millimeters. So a very precise instrument when it's combined with GPS signals and other things. So, and we plan on easy mounting and flexible IMU integration. And we already have built-in storage. That will save time. So if we look at our ranging performances here, So obviously we have to take into a lot of account with ranging. But if we just look at the key ones here, so at a high speed scan, you're still talking 360 feet of range. And now this isn't just a single target return where you get one pulse back, one pulse out. If you are going through objects like canopies and trees, you penetrate through those tree layers down to forest floors. Not every single pulse, mind you, but the ones that can get through the thinner branches. So now you're getting multiple returns from a single laser pulse, which really helps you capture a fuller picture. We'll get a little bit further into this. Different operation modes yield different ranges. So when we talk about in the range performance with this capability, if you're flying in an urban environment, for example, obviously we are putting aside any talk of regulation issues here. This really has a unique way that allows us to couple what the ground surveyor is able to survey with a tripod scanner with getting information on top of the building that isn't accessible to them without figuring out a unique and challenging way to get a tripod-based scanner up high enough to then see on top of a roof of a building. That's, it's going to be more time-consuming, and it's going to be very difficult to achieve that. So with a UAS sensor that you can pull out of your vehicle, you can fly up, scan the top of the building, come back down. That's one class of an example. Yeah. And so if you look at the kind of point densities we're talking about, this is a very information-rich point density. At 57 points per square meter, that's a lot of information to have collected by a LiDAR sensor. And the unique aspect of LiDAR sensor is this is not light dependent, so it doesn't matter what the lighting conditions are, it's providing its own illumination. So you're able to see this at day or night. It doesn't matter if it's high sun, low sun, you still get this information. And then this information can, of course, be combined with photogrammetry information. So when we talk about our field of view, it's a 330 field of view. We have a small little connector that helps for electronic support and stability of the sensor that is blocking the full 360 view in this first version of the instrument. So this allows us to get a very clear coverage. Obviously, depending on the type of aircraft you're going to mount this to, you're not going to, missing 30-degree field of view is probably going to be something that's going to be more than expected to happen due to the fact that you actually have an airframe body above it. So let's talk a little bit about multi-target capabilities. Just a little breakdown here. So here's your emitted pulse from the sensor. Sometime later it hits the tree. Sometime later after that it hits the shrub, and then finally this last echo. All of these echoes here are extracted in real time on board the instrument. This isn't something that happens, after 20 hours worth of effort to get one target pulse. This is in real time target extraction on board the instrument and saved right to its onboard system. So when you have a ULS sensor, it's just like all our other sensors in the way that we have to combine multiple technologies out there. We need to be able to combine it with an IMU sensor to provide higher accuracy information in terms of its trajectory. As we talked earlier, autopilot systems are going to get you close, but they're not going to get you down to the inch scale that farmers are looking for precision ag, or the scale of millimeter quality data that we're looking for in typical survey applications we saw yesterday with a comparison of a UAS sensor versus a traditional LiDAR aircraft. So to compete in this space with multiple sensors available out there, combining these is going to be where the system succeeds at. Then, of course, you have to have the right software. You can't just go out there and hope that everything comes back down. We have our own software that's created to remote control the system. This has been embedded in our sensor for the use on the Regal aircraft. So we have many experiences working with a UAS manufacturer to make sure you can get the proper command and control done. So I'll run it. It stores all the data on board, which makes it really easy. Controls image acquisition as well. So this will allow you to do image acquisition with it. And it collects all the information from the IMU system, so you get your whole trajectory path. And then it brings it all down and transfers via video link so that on the ground, you actually see this footprint of exactly where you're scanning. It gives you health information about the vehicle at all times, or about the sensor at all times, I should say, which really helps you know exactly what's happening. Because if you go up and spend time collecting data, you want to make sure that you actually collected the data you intended to. So we are in the early stages of getting this instrument out into production. We hope to have deliveries done this summer, so be looking forward to having some presentations done here in North America in several test sites throughout the summer here. Currently, here are some examples of some of the integrations that have been put together for various companies who have risked it by going ahead and purchasing a system over in Europe. You can see here is the AeroScout integration. It's a very nice compact package for the sensor. I believe the AeroScout can carry around 40 pounds of weight for several hours. Some Norway system as well. Here is a rotorcopter as well. I think they actually 3D printed their own sensor because, as you can see in the close-up here, it's more of a mock-up than we have. So then here are some of the ideas that Regal's come up with for creating a common platform that will mount on several different types of air vehicle. And of course, as you can see here, very key to this type of work we see will definitely be incorporation of RGB camera information. So that way you can collect high-quality photogrammetry information along with the LiDAR data. This gives you a really full, rich environment for being able to extract many different types of information for clients. So, how do we see this being used and utilized? Well, here's our quick brainstorm of many areas where we can see LiDAR services being very applicable to the existing markets. So we have environmental monitoring, where we can take, so if we go back, there's the LiDAR data. It's very dark, of course. It won't show up. But when we add some color to it, this is just the ground conditions. So we removed a bunch of trees and vegetation from our data set so you could get the exact ground topography. From there, we can identify properly the vegetation. So if you couple this with some infrared imagery or multispectral, you now can do species identification. You can at least do growth, height, and monitoring over time. You can create terrain models for erosion. And of course, you can look at the shrub layers and the deadfall in forests, all from a quick couple-minute flight. Some further applications, of course, are you taking your 3D point cloud, classifying the data, looking at encroachments in power line corridor sectors. This is done pretty much every day in the U.S. with our helicopter systems that are already in the field with the same LiDAR technology behind the VUX1. So, in short summary, there's a lot of great opportunities awaiting out there for this whole industry. And where it goes in the next couple of years will be very exciting to watch. There's a lot of different sensor types that are being proposed for use on UAVs. This happens to be one that is already ready to go from a survey grade for mapping data, for survey and mapping data. And it'll be just interesting to see exactly what areas of applications the user community comes up with that leverages this technology. And we look forward to being a part of that and watching it grow. There we go. So there's the quick one. Ta-da. All right, so thank you. Questions?
Sounds like you nailed the check.
That happens. All right. Thank you.
Thank you, sir.